Hello everyone. Today we're going to complete the square again, just like we did in our prior video, but this time it's going to be a little bit more complicated. So you might see something like this and be told you need to complete the square, which is a way of solving this quadratic equation, and you may not know how to handle it, particularly since there is a coefficient other than 1 in front of the squared term. You've come to the right place because I'm Professor Capko and I'm going to show you how to easily do this. But first, I wanted to mention that I believe something great is going to happen for you today. All right, into the video. We're going to complete the square on this quadratic today. And if you don't know what completing the square is or haven't seen it before or need a refresher, you should start out with the first video, and that will show you a very simple completing the square. Before we get to this, I've linked that video up here for you. Take a look at that one and then come back here to see when we kick it up a notch. All right, let's complete the square and solve for x. And because it's quadratic, remember, we're going to expect to have two solutions. So when we get to the very end, expect to have two solutions. The first thing we need to do is understand that what our terms are. This coefficient in front of the squared terms, and again, I'm using x. These could be y's, they could be any other variable, but it's in this format: a squared term plus or minus another variable. It should be the same variable, but it's not squared, and then maybe plus or minus a constant equal to 0. The constant is not necessary, but you have to have this term and you have to have that middle term. This first coefficient, which is the number in front of the variable, we're going to call that our a term. And the coefficient here in front of the middle variable, that's going to be our b term. And the constant here at the end, that's going to be our c term. Keep that in mind because that's a format that's used even with quadratic equation and other things. So don't forget that we're talking about the coefficient, the number in front of the variable, not the variable. The first step then, what we're going to do is we need to move this c term to the other side. Some folks will just easily know that you need to just change the sign and put it over here. But the reason being, if you're not sure, is because we're subtracting 3, we're going to add 3 to both sides. That way we've done the same thing to both sides. And I'm going to rewrite it. 2x squared minus 10x. Negative 3 plus 3 is 0. And then 0 plus 3 is 3. So step 1, check, completed. We always start out with moving that constant term to the right-hand side. The next thing we need to do is we need to get rid of this coefficient here, the a term coefficient, the a coefficient. If it's a 1, which if there's nothing listed here, it would be an invisible 1, then we can leave it. But because it's something greater than 1, we need to go ahead and deal with it. And the way to do that is to divide both sides by whatever this coefficient is. So I'm going to rewrite this: 2x squared minus 10x equals to 3. And we're going to divide both sides. That means every single term we're going to divide by 2. We're dividing them all by 2. All right, so 2 over 2 goes away. That becomes a 1. So this is x squared. Negative 10x divided by 2 is negative 5. And then 3 halves. We're going to leave that as is. Don't turn it into a decimal. Just leave it as a fraction. I'm going to push this up. The next step in the process, and it's the same every time, is we're going to add some number here. And whatever one we do on the right-hand side or the left-hand side, we're going to do the right-hand side. So to keep it in balance, we're going to add some number here, and we're going to add the exact same number there. So these will be the same. How do we figure out what number to add? Well, we want to turn this left-hand item, and I'm sorry, I forgot the x. there's an x here. We have to turn this into a perfect square trinomial. Perfect square trinomial. And the way we do that is we're going to take, again, we're going to take the b term, that's this term right here, the -5, and we're going to divide it by 2, and we're going to square it. So the format for that is the b term divided by 2, and we're going to take that whole thing and square it. And that's going to give us what we're going to add over here. So we're going to fill in the b term, which is -5. We're going to divide by 2, and we're going to take the entire fraction there and we're going to square it. And you know, with this power rule here, we're going to go ahead and distribute that square to each of those. So this is the equivalent of -5 squared over 2 squared. -5 squared is +25, and 2 squared is 4. So this becomes 25/4. That is the number that we're going to fill in here. So I'm going to rewrite that, x squared minus 5x plus 25/4. On the right-hand side, we have 3/2 plus 25/4. So our equation remains in balance. Because this on the left side is a perfect square trinomial, we can go ahead and factor that. That's very easily done. We know we take this variable and write it here. We don't have it squared anymore because this whole thing is going to be squared. So we're just going to write that x. And then once again, we take the b term and we're going to divide it by 2. So b divided by 2. So we have -5 divided by 2. That is what we put in here. So that's -5/2. On the right-hand side, we've got 3/2 plus 25/4. We know when we're adding fractions, we have to have a common denominator. So we're going to turn this 2 into a 4 by multiplying it by 2. And if we multiply the bottom by 2, we have to multiply the top by 2. So 3/2 becomes 6/4 plus 25/4. So we're getting closer to being able to add those together. All right, our next step is let's clean this up a little just so it's easier to work with. We have x minus 5/2 squared is equal to, and we can add those together, and 6 and 25 is 31/4. So it's getting closer to where we can solve it. Because we have a squared term over here, we're going to use the square root property, and we're going to take the square root of our x minus 5/2 squared. And when we do that to the left side, we're going to do it to the right side, but don't forget, we have to take the plus and the minus of the square root of 31/4. Don't forget that part there, plus and minus, and that's where we're going to generate our two solutions. Because we're taking the square root of a square, this is super easy. All we do is take out what's in the middle here, what's deep in here, and pull it out. This becomes x minus 5/2. If you're finding this helpful, it would really be great if you could square root that like button. I'd really appreciate it. All right, so we've got the left-hand side done. Now the right-hand side, let's not forget we got plus and minus. Because we have a square root of a fraction, just like where we split up the fraction with the exponent, we can do the same thing with the square root. So you have square root 31 over square root of 4. So all I did was split it up. This was the square root of the entire thing, so we're just doing the square root of the numerator and the square root of the denominator. The next step is, let's clean it up a little more. We got x minus 5/2 just copy that down, equals plus or minus. Square root of 31 is not a perfect square, so we're going to leave it as square root of 31. The square root of 4, however, is 2. 2 times 2 is 4. So we've got that cleaned up on the right-hand side. We want to get the x by itself, so we're going to add this term to both sides. So I'm going to add 5 halves. Add 5 halves to keep it in balance. So I've got x on the left side, and on the right side I've got 5 halves, and we've got plus or minus square root of 31 over 2. Push this up a little bit more. We notice that we have a common denominator here, and so we can now add these together. We can add them and subtract them. So you have two possible answers here. You have x 5 plus equals 5 plus square root of 31 over 2. And the second answer is x is equal to 5 minus square root of 31 over 2. Some people will just write it combined, and this is appropriate too. You can just go x is equal to 5 plus or minus square root of 31 all over 2. And that's one way to write both solutions in one spot. So that's how we do complete the square when we've got some number in front of, in other words, a coefficient other than 1 in front of our squared terms. I hope you found this helpful. If you did, go ahead and subscribe to this channel, because we're going to do some more tricky ones like this, as well as other things. So keep your grade alive and subscribe. Thank you.